Yeah, once again, my name is Dan Yeaw. Really excited to be doing this matching text with regular expressions talk. We'll have a lot of fun with regular expressions. Hopefully, we won't make it too boring because it's kind of like text matching, but we'll make it good. So what is a regular expression? So it's a sequence of patterns that specifies a match pattern in text. So this allows for all kinds of things, like think of it like finding something in text and be able to grab that thing you want and maybe just a part of it. And then you can do things like replace it or filter out things, or it becomes very powerful to um, kind of a superpower for programming. It's also known as a regex, which stands for regular expression, or RE is the Python module that we're going to use. This is a hello world example for a regex. So you import RE, that's in the Python standard library. And then we're going to create a string called hello world. And we're checking if re.match, and the first parameter we're passing in is the actual regular expression. And the second parameter we're passing in is the string. Some of you might not be familiar with this R in front of the regular expression. That stands for a raw string. And what that does is makes the slash, the forward slash character act as a normal character. Because normally in a normal string in Python, like something like /n would be a new line. And so it would try to like interpret that slash as a special character, but we actually want to pass that character to the regular expression itself. So you need to use a raw string when you're working with regular expressions. And then we're looking for hello world, and the around the L, there's some brackets around it, and we'll learn more about that. But that's a set, so it's looking for the L in the set. And then the curly brackets after it with a 2 means there's 2 characters. So it's looking for 2 of the thing in front of it, which is L's. So it's looking for 2 L's. And then an O, and then the dash or /S is for a white space character. And then world. You also notice like the hat symbol at the beginning and the $sign at the end means the beginning of the string for the kind of hat symbol, and the $sign is the end of the string. And so this is saying if we find this match, which we would print found it. So that's like a basic regular expression. We've already seen some of these like weird characters that we're going to make use of in the regular expressions as well. An XCD comic, KCD comic. So at the end, our goal is we're all superheroes with regular expressions of this talk. So in the comic, we're swinging in like Tarzan, doing some regular expressions, and then save the day. So we'll try to make it so that everyone's feeling like that at the end. And the example for this was like parsing through emails, right? And that's kind of like an example of like this, parsing through some big amount of text, thousands of email addresses or something that you can do with regular expressions. This is also a really famous quote. It says, "Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have 2 problems." And that's from Jamie Zawinski, who is one of the founders of Netscape. I also like to think of regular expressions as the hot sauce of programming, because hot sauce is great if you use a little bit of it, but if you use too much of it, you end up burning your mouth. And the reasons for that is regular expressions are expensive, so they have a really big performance hit for their computer actually to calculate the regular expression. They're also greedy, which we'll talk about more about what greedy versus lazy means. But often it's very easy to match more than you were intending to. So like say you were trying to match some HTML characters, it's really easy to accidentally match like 2 tags instead of what you were trying to do. And they're also like kind of opaque. Once you write it and you're like, oh, I got that to work, giving it to someone else and saying, here's my regular expression, they're like, what is this? Very terse and kind of hard to read after you create them. So just use them a little bit, and they are very powerful. This is an example of that. This was not written by a human. It was done by, this is in Perl, which is a programming language that used a lot of regular expressions. And they actually concatenated a bunch of regular expressions together. And it's the RFC for an email validator. So you can see how complex something like an email specification can be. But this is this is way too much regular expressions. No one would ever be able to figure out what the heck all that is doing, right? So don't try to don't try to create that. Another thing I recommend is first to try to utilize other things in Python. So regular expressions should be like your last resort of like, hey, this is really hard to do some other way just with standard Python. And one nice thing you can use in Python is just Python's built-in string manipulation is really nice. So for example, you can check if a string is in another string by doing hello in hello world, or you can split a string into 2 parts, for example, on the white space, or you can split on any character if you pass it in. And so this created a list of hello and world. And then you can like, hey, I only wanted the first word. You have it in a list. You can just call the first word now, right? Or Python also has this nice way to slice strings. So if you just want the first 5 characters, that's what this :5 is doing, to slice the string and just getting a portion of it. Or there's other things like starts with. So you could check if a string starts with something. Those are just some examples. Python has a lot of like built-in string manipulation. And that is always, always way more readable than like a regular expression. So if you could use something like that, definitely I recommend it. It's also not for parsing. I would recommend, hey, how's it going? I would highly recommend not using regular expressions for trying to parse things. So I mentioned like the example with HTML where regular expressions are greedy and it's very common to capture more than you are trying to. There's whole libraries. There's a really good one called Beautiful Soup, and they're designed for parsing HTML or scraping websites, right? And so if you think you need to use a regular expression to parse something to, get the tags in an HTML file or something like that, normally there's a library that could help you with that much better than trying to write a regular expression to like pull a tag out or something like that. Okay, so I told you about all the things to avoid of not using regular expressions. But if you have to use regular expressions, some main uses are something that you'll use once and then throw away. You get your regular expression to work and then you're done with it and you don't care about it anymore. So an example like that, you can often do advanced find and replace like in your Python IDE. And so you would like search for something, replace something. It's gone now. Like you're never going to use that same regular expression ever again. And no one has to read it again, right? That's a really nice way. Other things that regular expressions are really good at is for string validation and string manipulation. So this is, by what I mean by validation is, hey, is this string that I got in the format of an email address or a phone number, something like that? That's kind of like a validation. Once again, you want to think of, is there some other way I can do that though? Because if you're making a website, there's often whole libraries for like parsing form data and checking if something's an email address or something, right? But a regular expression could be a good way to do that. Or manipulating and changing a string like, hey, I want to take the first part of this string and the last part of this string and combine them together. It's really nice for things like that with these groups. Okay, so we're going to go through some of the common regex characters. maybe I'll pause for a second. Is there any questions, anyone? All right,
Yeah.
hopefully. Yeah, go ahead, online.
Is this like a
Suresh?
universal kind of a language, meaning is the same kind of syntaxes, whether it is Python or any other language, or is it Python specific?
Regular expressions are pretty universal. So Python has the RE module that implements regular expressions. Some of them have some unique capabilities that aren't available in all implementations, including Python. But for the most part, like we're going to go through these regex characters. This is like what it's defined in, no matter if you're doing it in JavaScript or Perl or using a command like tool like sed can RC or grep can use these things as well. So the regex language is kind of like cross languages and has good support in Python.
Thank you.
Yeah, thanks, Suresh. Okay, so we're gonna kind of go through some of these common characters, and then we'll go through like some examples. So bear with me for just a second, but we saw some of these already. We at the bottom, there's the beginning and end of line. We saw that in the hello world example, for example. So the dot is very important for regex. It matches any single character except new lines. So you could say, hey, I don't care what this character is. I'm looking for, a character with something after it. So you can use a dot for that. The escape a special character. So the example there is if you wanted to actually, since dot is a special character, if you actually wanted to look for a period in the string, you would have to escape the period. So it escapes whatever the thing is, the special character. And then there's a lot of things that make things optional or, greater than one. So the question mark is the optional thing. Like this could match 0 or 1 of these things. The star is 0 or more. So and once again, regex is normally called greedy. So it'll try to match as many as it can. So if you had like 3 E's in a row and you put E star, then it would try to match all 3 of them. The plus is 1 or more. So the you can see that the plus would be you have to have 1 match, or it could be more. The star could be 0 matches as well. So like the star is kind of the optional plus the plus together in a bit. There's the pipe symbol, which is an or. So you can see in the it's called a group with a parentheses. So hello, and the pipe mad would match hello or mad. We're going to talk more about groups in a second, but the parentheses is for grouping things. So you may want to put certain parts of something in a group, and then you can, if you want to, you can make use of those groups later. Like I mentioned, hey, I just want the first word that would be in a group, and I want the last word that be in a group, and then I want to put those 2 together. And so you can make use of those 2 groups after the fact. So it kind of like saves them for later use. Yeah, go ahead. Mm-hmm. In Python, it is Unicode capable, and so is like their regular expression. If you put A to Z, it's not going to include Unicode, but you can do like Unicode code points and all that type of stuff. So you could match like Unicode characters. Yep. And I don't know if everyone heard the question online. So the question was regex Unicode capable? So that was for grouping things. So then we have the curly brackets. You could specify how many of the preceding characters. So this example there, A and then curly bracket 12, which means there's 12 A's in a row, and it would only match that. And it's always that preceding character. But you could once again, create a group of multiple characters and then say, hey, A and B is in a group and I want to match 12 of A and B. So then it's looking for A, B, A, B, A, B 12 times, right? The brackets matches any character in a set. In the Hello World example, remember there was the L in the brackets, and then we matched 2 of them with the curly brackets. So that is the set. So if you put more than one character in there, then it's going to look for, if you put A, B, it's going to look for A or B in the set. You can also put A through Z, so you can match groups of things, or 0 through 9, and it'll look for any of those characters in that, A through Z. And we talked about the beginning and end of line. There's also some character shortcuts. I know this is kind of a lot to go through, but we'll get to some fun examples in a second. So those are the characters, and then these are the character shortcuts. And remember, that's why I said, hey, we have to have raw strings with Python, because we need to pass in these character shortcuts. Otherwise, it's going to think you're trying to like enter a special character. So a shortcut for a digit is the /D. And so that's a digit from 0 to 9. So the example is file _ digit. So that would match file 25 because there's 2 digits. Lowercase w is a word character. So this would match any ASCII digit, Unicode, or ideogram. So if you have a character dash character, that would match A dash B _1. So it's any type of character. And S is any type of white space character. So that could be a space or new line or tab, Unicode separator, anything. And so that could, if you had A space B space C, you could use the /S as the white space. And then the capitalized ones are kind of the not of the other ones. So capital D is not a digit, and capital W that is not a word, and capital S is not a white space. And then finally, there's lowercase b, which is a word boundary. So if you had hello world and you wanted to say, hey, this is the word boundary, that would be like the space in between them. So it's like the boundary between. All right, so let's show an example. So we have all this power. We know all these characters now, but doesn't necessarily make it easy to say, read that if someone handed it to you, right? It's like, what is that? We want to validate a phone number. And if you pretend a phone number is just more than, 9 digits or 10 digits in a row, it could also have a plus in the front. It could have dashes between sets of letters or numbers. It could have a space or a period between them. So this is like a validator for that. And I'm also using this ihateregex.io website, which I think is really nice for both common regex of like, hey, I want a regex for a phone number. You can just grab it from this website. And they also explain on this website, like visually how it works. So I think that's really nice as well. And in just a second, I'll go through the whole regex with comments as well. But if you see in the beginning of this, there's the like hat character, which means like the start of the line, right? And so you can see at the beginning down below, it says that's the start of the line. And then it wants to match, possibly there could be a plus in front, like +1 would be our country code for the United States. And so it's got it in brackets, which means a set of, and it's escaping the plus because the plus can also mean one or more, right? And so it's saying, I want to look for that actual plus character, and it's optional because it's got the question mark after it. And you can see down below then it says one of plus, and then there's also the optional, which is the line that can bypass that one of, right? So the line around it means like that's an optional character. And then same thing. So the area code sometimes has a parentheses around it. So that's optional. So you could have an area code with parentheses. And so we check for a set of opening parentheses, and it's optional. So the question mark. Then we're looking for 3 numbers, 0 through 9. And so it's a set of 0 through 9. And there's exactly 3 of them. And then there's an optional close parentheses. And then we have some type of separator, maybe. So it's a question mark, and it's a set of dashes or a set of white space or periods. And so that's what the brackets could be, any of those characters. And it's optional. And then we're looking for another 3 numbers. And then we're looking for those separators. And then we're looking for 4 to 6 numbers at the end. And that's kind of what it's showing at the bottom as well, kind of visually. And so you can see when there's more than one, there's kind of this you go through once, and then 3 to 5 times more is kind of like the cycle on the visual thing. One other way we can write this is actually using comments, because if you put that last thing in your code and someone has to maintain your code, or even like a week later, like, what the heck was this? I have no idea what I wrote. Maintenance of regular expression is really hard. So this is really nice. You're using the triple string quoting, which allows you to put a string on multiple lines, and then putting a comment on each line in this string. So this is an actual regex. It works exactly the same as the last one, except we're putting comments for each step. So we say start of string, optional any character instead of plus, optional parentheses. So we're putting all the comments for what each step does. And now you're like, oh yeah, this isn't that intimidating now. I remember what this was. One thing you have to do special is we're doing a re.search, which is searching for that pattern using Python. And so you put in the pattern you're searching for. The second one is the string you're searching, and that'd be like a phone number. This phone number has a plus on the front. And then the last attribute there is called a flag. And so Python has special flags for options you can pass. So there's flags for like, hey, I want to match this multi-line. I want to match it on every line. Or flags like verbose, which ignores the new lines. That's what actually allows you to do this. If you don't use that re.verbose flag, then it won't match the multi-line regex, because it won't identify. It'll think that there's new lines in there, and it'll be like, oh, that doesn't match. There's no new lines in your phone number, right? And then what that re.search does is it returns a match object. And then the way you actually get the match out of the object is you call .group on it, and then that will output the phone number. And so you could also, we're going to talk more about grouping in a second. You may want to not the whole match. You might just want a portion of it, and then you can just grab that group from it at the end. Okay, so we can also use this for substitutions. So this is how you would substitute. So we're doing re.sub is a substitution. The regular expression is hello world again. That's the one we looked at before at the beginning. Maybe you can also see that we have 2 groups now in this hello world, the parentheses around hello and the parentheses around world. So there's 2 groups that we've created. And we want to replace it with this mad, and we're telling it for the second group there. So this is taking in hello world. We're saying we want to substitute hello world with mad world, and it's doing a substitution based on the groups. So that's like how substitutions work. Okay. Talk more about groups. So once again, groups are defined by parentheses around things. So this is our string. The meetup, my Python has 2,149 members. That's our string we have. And then we want to search that string, and we put 2 groups in there. Remember, the /b is a word boundary. And so we have word boundary set of A through Z and all capitalized. So that would be looking for a word that's all caps. Word and the plus is one or more, right? And then another word boundary that's in one match, one group. And then the dot, which is any character. So one or more any characters. And then we're looking for another group with a word boundary and one or more digits. So the first group is looking for a all capitalized word. The second group's looking for some number of digits. And so you can extract this result and look at the groups, and it prints out Michigan Python and 2149. And you can also just output group one. So like, hey, I captured two groups. I actually just want the number. So you can print out, or excuse me, I actually just want the capitalized, or for the second one, I just want the number. So you can just pass in 1 or 2 for the group number, and it'll just return that part. So that's how groups work. That's really handy because, say, if you have a lot of strings, you might only want to pull out a portion of the string and then reuse it somewhere else, or create a whole list of just those numbers or something like that. And so being able to capture those groups and use them later is really important. We can also use named groups. So to define this, it's the same group syntax, and then you put a question mark P, and then you pass in a bracket name. And so this is a Python's version of how you name a group. And so this is the same thing. We have a group, two groups. One we named first, one we named last, and they're both looking for a word, and there's one or more words there. And we pass in Jane Pythonista as a name, and you can see you can call that match object dot group dict, and it'll actually print out a dictionary with the first match's name and the value, and the second match's name and the value. So we have this dictionary, Python dictionary, with first Jane and last Pythonista. So that's how you like it works the same way as regular groups. It's just kind of nice for like, you don't have to say group one. It's like a dictionary with the name and the values. Okay, so regular expressions have this thing called lazy and greedy. And we talked about how by default, regular expressions are greedy, which means they match more than probably you were intending to. They try to match as much as they can. So you can also make your regular expressions lazy. And an example of that would be, we said the star was 0 or more. So you can also do a lazy quantifier, which matches the minimum. So instead of like 0 or more, if you just use a star, it will try to match, like if there's 5 A's in a row, it's going to match all 5. The lazy one is going to do the opposite. It's going to match the minimum. So the same thing for plus quantifier, optional 0 or 1. So these are trying to, instead of being, it's called lazy because it's trying to do as minimum as possible rather than like trying to match more than as much as it can. You can see normally we add the question mark to turn something into a lazy quantifier instead of a greedy. So if you had a number like the last one, 2 to 3, with a greedy one, if there's 3 A's in a row, it's going to give you all 3. With a lazy version, if there's 3 in a row, it's only going to give you 2 of them, because it said, oh, you said 2 to 3, and I'm giving you the minimum, right? The 2 instead of the 3. All right. This is where things get pretty wild, but very powerful. They're called lookarounds. And I'll show an example in a second. So these lookarounds allow you to not just match text, but look in front of what you're matching and behind it and say, hey, I'm going to only match this word if it's followed by the word the. or precede, or the is before the word. Or, hey, I'm going to look out in front and we'll see in a second, like a password. I need these types of characters in my password. You could do a look ahead and say, hey, do I have a special character in this password somewhere? So those are called lookarounds. The look ahead is looking in front. The look behind is looking behind the characters you're matching. And you do this by creating once again, the parentheses for a group. A question mark equals is the look around. And then the look behind instead of the equal sign is a less than equals. The negatives are the exact same things, but it's a inverse or a not of the normal look around. So I said, hey, I'm only matching this word if it comes after the word the. It's instead of that, it would be only if it's not following the word the, right? So it's a negative look ahead or negative look behind. I feel like that's a tough one to noodle on. So let's look at an example. Let's now look at this minimum password requirement. So this is very common, like when you're signing up for something and they say, hey, your password needs at least one uppercase English letter. It needs one lowercase English letter. It needs at least one digit. It needs a special character, and it needs to be 8 digits long, right? That's like a pretty common like password. So what we're using here, once again, these are the look aheads. So the question mark equal. So it's looking for doing a look ahead, and it's looking for any 0 or more characters, and then in the group A to Z. And same thing, lowercase, 0 or more, and it's lazy, right? Because there's a question mark. So we have the 0 or more lazy, because it's that, because you want to, if you see 1, you're like, yep, I'm good. And same thing for at least 1 digit. So it's not going to try to, if it finds at least 1, it's going to match. And then at the end, the minimum 8 characters. So you have a dot, which is any character, and then the brackets for 8 is the minimum. So let's see what that looks like in our diagram. So this is the same thing where we individually said uppercase, lowercase, digit, special characters, number of digits. And you can see the positive look ahead. So it's looking any character, one of A through Z, or positive look ahead, any character, lowercase a to Z, or any character digit, or any character in special characters. So it's only going to go to the end. This is a positive look ahead. So it's looking in front of the match. It's only going to get that any character, 8 different characters if all the positive look aheads succeed. So it's like, hey, I looked ahead in your password you wrote. There's lowercase, there's uppercase, there's special characters. Okay, I'm also going to match if there's 8 characters. But if one of those don't succeed, so if it does the positive look ahead and says there's lowercase, uppercase, digits, but not a special character, it will not match because we'll never get to that 8, counting up the 8 characters. I'll maybe pause for a second. Is there any questions about lookarounds? Everyone's mind blown. Okay, so we're going to, I also wanted to mention some really helpful websites. So we talked about the I hate regex.io one. That's really good. This is also a really good one, Regex 101. And what these websites allow you to do, there's also one called like Regexer. They allow you to enter some things you want to validate. Like, here's 5 different phone numbers I want to match, and I want to match all of them. And then allows you to interactively type in on the website your regex, and it will show you the matches as you go. Because otherwise, it's kind of hard to sit down and just like, here's my regex. I just wrote it. and being able to iteratively maybe even start with the first phone number of like, hey, this one is just 10 numbers in a row, and then oh, this one has a plus, and kind of incrementally work on your regular expression is really powerful. And also it helps see what matched and didn't match. So some of these websites are really nice for that. The other thing you can see I put in the comment here, regex 101 lets you save your regex like forever. So like, remember, it becomes hard to maintain this stuff. You can put, here's my 5 phone number examples. Here's a regular expression I made. And we created a phone number pattern. And this is kind of like your documentation for your regex in a way, because if someone's like, I don't understand this regex at all, they can just go click on the link and see the regex in the web browser on how you created that regex. And then they can manipulate it and kind of figure it out. So that's like a nice way to document your regular expressions, that someone can just go look at what you actually use to build the regular expression and can learn that way. So that's what I wanted to go through. And I think Evan's got an example as well, because he uses a lot of regular expressions in his day job. And so I will pass it off to Evan to go through an example. Yeah. I think you're. Oh. Mute this guy.
Testing, testing. Can y'all hear me? Okay. Okay. Awesome. So, and screen sharing is enabled, right?
We do not see your screen yet.
Yeah, I haven't tried it yet. Make sure it'll work if I do. Okay, cool. So yeah, I deal at the law firm where I work, and I basically design workflow automation for the firm. So I'm wrangling data and I'm wrangling files all the time. And we get a lot of files from clients that have to be, associated with the proper account, and they get stuff that's crazy and different all the time. So one of the things that I have to do is figure out how to match the files to the proper accounts and how to categorize the files correctly. Knowing that usually there is some human being on the other side who is fat fingering in things with little rhyme or reason or uniformity. So that's where regex comes in super handy for me. One of the really fun filing patterns that I have to deal with a lot are these right here, this first grouping. You see lots of digits in there. You can tell at the end, this looks like a timestamp basically, so that's easy. But that's not what I need. I need an account number. The sort of account number we have in our system. And it turns out we don't use this whole thing as an account number. It's just the way things were set up. The account number is actually this portion right here without the hyphen. And you can write a really simple regex for that. And you can do these regex searches within your IDE. I'm using PyCharm like Dan, and you'll see the matches, boom. But it's even more fun to plug it into something like regex 101, because regex 101 will also give you this great explanation of what your regex does. You didn't have a slide with an example of that, did you? Okay, that's one of the coolest things about that site. So big fan of it. And there you go. It's showing you exactly what's happening. So we've got this first group here, which I don't care about at all. So it's 1, 2, or 3 digits followed by a hyphen. So there's the group 1. And then group 2, which I need, and then a hyphen that's ignored. And you can see the hyphen doesn't come out in the matching group because it is in this right here, which is a non-capturing group. That's the question mark colon. So the hyphen isn't even captured. We're just getting the digits here, digits here. And one of the cool things about using the group method of a regex search attempt is that the single method of this just group parentheses will return the entire match, but you can actually put in group numbers to get specific back if your pattern had groups in it to begin with. So I've got a simple method that's calling group 2 and group 3, and it's putting the two of those together to get the account number that I need. So that's how I deal with that particular one. This one's a little bit better. This one actually is really, really uniform. It's 2 digits followed by 5 digits. So that's very simple regex. We do want to make sure we're starting at the very beginning of the string. So you've got the caret here to denote the beginning of the string, and then you're looking for a digit, specifically 2, followed by a hyphen, and then 5 more digits. And so we can throw this into regex 101 as well. And oops. And we'll put our pattern. Oh, also, if you are messing with the site, make sure you've chosen your flavor of regex. So I've specified Python over here, and the flags, like the flags that Dan was using with the RE dot verbose, or you can do RE case insensitive, all that sort of stuff. You can match those in regex 101 by clicking here and just checking off the ones that you want. So I'm usually doing a case insensitive search. That's one that I always have turned on. It turns on global and multi-line by default if you're on this site, but you can turn those off if you don't want them. So those are the matches here. And if I were to just return the group, like the group paren without specifying a number, it's going to give you the entire match. And as you can see, this pattern, unlike the previous pattern, doesn't even contain groups. So your only option to get a result from it is to get the entire match, which you're going to call the group method to get that. So let's do one more real world example. This client's more fun. They usually put an underscore after their account number. These are all obfuscated numbers, by the way, just so you know. They usually put an underscore after it, but not always. Sometimes it's just a space. So this is a simple regex to start at the very beginning of the string, and then we're using a set here. Did you do any negative matching sets? Okay, so this is we didn't go over this. If you're setting up your set and you're doing 0 through 9 and A through Z, whatever, it's just going to match those whatever's in that range. But if you use as a prefix a caret, it means anything that is not part of that range you have defined in your set. And the caret outside of a set means the beginning of a string, but inside a set, it means not these characters. So I'm literally, this is creating a set that is not an underscore and not a space. And we're going to look for that set a greedy number of times. So it's as many times as it can. We'll go ahead and paste that into regex 101 and watch what that does. Boom. And there we go. So it's ignoring the spaces. I mean, it's basically stopping when it sees a space, and it's stopping when it sees an underscore. And again, you've got your great explanation over here. Positions the start of a line, match a single character not present in the list. I guess it's called a list, not a set. I'm sorry. Anything not in there, and a plus means it's going to be 1 and unlimited times, which AKA greedy. The other challenge we have is trying to label the content that we get. So we get a lot of certain types of orders that need to be denoted as orders, but not everything. Like this one right here, this order extending, we don't want to categorize that in our system as an order because it's sort of an anomalous thing. So we want that to be ignored. So I've got a pattern here that will search for order, case insensitive, unless the word order is followed by the word extending, because that's one we want to ignore. So this is a real world scenario of using the lookarounds, which I think was the last thing that we covered. And that is super duper handy because it will grab everything that has the word order in it, except the very last one. So you've got a match here, you've got a match here, and there's no match here, simply because we have defined the negative look ahead, which is basically just any characters and the word extending. So if it sees that word extending in there after the word order, it's going to ignore it, but it will get every other file name that has the word order in it. So I've got dozens of these. They're usually specific to each client, and we use them every week, and it makes my life much easier. This all had to be done by a person by hand before we had this sort of stuff set up. So I think the last thing I was going to show, we were talking about using regex in the IDE to do complex finds and replaces and stuff like that. I use that all the time too. And sometimes it's as simple as taking, like, you've got a list or something and you maybe you need to plug this into a SQL query with like where this in this, and you can jump right into regex and search for new line, comma, space, boom, you just flatten that out. So super handy. Or if you know you're searching for strings instead of integers, you can throw in the other characters you need right here as well, and then run your replace. Boom. Now they're all little string searches instead. So really handy stuff. And I will say that the regex flavor being used in the PyCharm, it's not pure Python regex. Some things don't work exactly the same in here. Be careful with that. You can documentation out and it tells you all the variations on it, but it's still super duper handy. So yeah, that's that. Any questions on that? Well, I guess we need to flip here.
All right, thanks, Evan. That was great. Any questions online or in the room?
Yeah, I have lots of questions, but I came in so late that I only heard the last topic. So I was wondering if the earlier part of the presentation would be available for me to look at later.
Yeah, so we'll have we'll post this on YouTube, and it'll be there at youtube.com/C for channel /Michigan Python, and so you can view the full beginning of the presentation as well, and or share with your friends or any of those things.
Thanks.
Yeah, thanks. I think we had a question in the room.
Yes. I have a question. So far, we've been using the regex to validate someone's inputs. They say they enter a phone number and they enter just numbers. None of the spaces in between or anything. And it validates because it's correct. It's got the correct number of digits. Can you then use regex to format the number on the display if you want to? Can it be used to say, okay, here's the 9 digits. Here's how I want it formatted. Parentheses around the first 3, and then a space, and then the next 3, and then a hyphen, and then the last 4. If you wanted to do that, does regex do that, or is it just more for pattern matching in the first place, not for formatting after the fact?
So that's what you can use a groups for. So you can use your groups to say, hey, I know we're just entering 9 or 10 digits, but the first 3 digits are part of this first group with the parentheses. Then this, second 3 are part of the second group. And then you can use those groups to print out group 1 dash group 2 dash or whatever format you want. So that's what the groups really allow you to do, to throw away stuff you don't care about or capture the groups so that then you can put characters or formatting and stuff around them as well.
And sort of the same vein, are they using regex online? Say the nicest things you see when you go on and if you pay for something online, you enter a credit card number. Some of the nice ones, as you start typing, you enter the 4 first digits and then it automatically puts in a space, enters the next 4. Is that regex, or are they using a private, some other library to do stuff like that?
They could be using regex for nice form validation or formatting. Or they could be using, there's like libraries that are designed for that as well. Like, I think there's like on the Python side, if you're using a web framework like Flask, I think it's called Flask WPF, which is for like web forms where it does, you can say this field is an email address, and then it validates that it's an email address, which is probably a lot more robust than trying to write your own regex of just using a library because someone figured it out, a really nice solution for it. But some of them may be using regex to format or parse stuff as well. So it probably just depends, I think.
Thank you.
Yeah, thanks so much. Hey, Rick, I saw you had your hand up online.
Yeah, just fabulous presentation. Really great tag teaming on, kind of some of the background and then some real world examples. One comment and a question. The comment is, I like that the introductory thought about, using tools that you have, like the Python split command, if you know that there's something in the format that you can utilize to try to grab pieces of information that you think are important, or that's where the relevant stuff is, and then using regex. I haven't used regex, so I don't know about this. But then you use regex to try to, look for the patterns within the characters. So I like some of the things. I mean, that seems like the most powerful way of implementing this. And then I haven't been at the meetings in a while, but I think I'm remembering a long time ago, Evan, that you might have given a lecture or a talk about, web scraping. And am I remembering correctly? Okay. And to me, this seems like wow, this would be fabulous for web scraping. So I didn't just a kind of an open question about, how much have you used this in your web scraping stuff?
Evan, do you want to answer that one?
Sure. Yeah, I actually, when I was in-house counsel at Funimation and also in-house coder, I had a team of people working with me to just find cartoons on the internet where they weren't supposed to be. So we were basically just logging infringement that we found online and then reporting it to the web hosts. And we had a slew of tools that we used, and everything was very heavily automated. And I actually taught my team to use some basic regex, and they were plugging in anime titles into the regex. And so you had a lot of the options. I don't know. Let me share again, because I don't think I covered this enough when I was first displaying it. The on the labeling pattern, I don't even know if I used it at all. Did I use the judgment labeling pattern? Let's see.
No, I don't think so.
Okay. Well, I skipped one. So here we go. So there's judgment. Let me find an example where we've got some other spellings here. Okay. So the well, it's okay, the alternative character. So you can put in a bunch of different stuff and it's going to grab all of these alternatives if you've separated it with a pipe here. And the question mark, well, it can be a quantifier, but it'll also let you know if the preceding character is just an optional character. So that's how we get the correct spelling of judgment. I'm going to call that the correct spelling. But we also get the alternative spelling of judgment with an E in the middle. So this regex will grab both because of the question mark. And it's also grabbing every different abbreviation that I've listed that this client uses of these different patterns. So that's super handy. And what we would do at Funimation when we were trying to find, Dragon Ball Z and all these other shows, sometimes our licenses would include like the flagship of the series, like Dragon Ball Z, and then a new one would come out like Dragon Ball Z Super, and we wouldn't have a license for that. So we're trying to find all these instances of Dragon Ball Z, but not one that says Dragon Ball Z Super, because we don't really have rights over that. So I taught my team how to do regex. They could find all those sorts of things. And there was a different regex for each title that we were looking at. And we're talking about hundreds of different shows here. So sometimes we were talking about doing Unicode searches with regex. We would also have kanji alternate titles for some of the shows. And you can write a regex pattern complex enough to handle all that. It's pretty cool.
Yeah, very cool. Thanks.
Yeah, thanks, Rick, for the question. Any other questions, anyone online or in the room?
Oh, you know what? Let me if y'all can see the bottom, is that font big enough? And this kind of goes back to your question. Using the groups, if you want to reformat whatever your results are, here's an example of that right here. So this is that really long file name that had the timestamp at the end, but we only wanted the first part. And even of that, we only wanted the the second and third groupings of digits from that file name. Well, here you go. I'm just printing it out with an F string. The identifier check, that's the results of the regex search. And then I'm calling specifically group 2 and group 3, and we're ignoring group 1.
Now, if I were to call just the group method itself, it's going to give the entire match. And if I wanted to go and get that worthless group 1, there it is. But otherwise you can pick whatever you want. And you're formatting whatever you want just as you're calling the group method on the search result. So yeah.
Any other questions, anyone?